This week on the show, we have the earliest Unix code, and we have a tutorial how to replace failed to ban with blacklistd. We also celebrate a little bit the OpenBSD crossing 400,000 commits. We also have a tutorial how to install Bolt CMS on FreeBSD. We talk a little bit about optimized hammer and appeasing the OSI 7-layer Burrito Guys in this week's episode of BSD Now. BSD Now, episode 323, OSI Burrito Guy. Recorded for the 6th of November, yes. And I'm Benedict Reuschling.
And I'm Alan Jude.
Welcome to this week's episode. We are still in the Unix is 50 years old vibe because we found another article called The Earliest Unix Code.
Or two,
yeah, there are a couple of them. But this one is The Earliest Unix Code, an anniversary source code edition or release.
Yep, so this is over from computerhistory.org, and they have a big blog post here. And it asks, what is it that runs the servers that hold our online world, be it the web or the cloud? What enables the mobile apps that are the center of increasingly on-demand lives in the developed world and of mobile banking and messaging in the developing world? The answer is the operating system Unix and its many descendants, including BSD, Linux, Android, macOS, iOS, etc. The list goes on and on. If you want a glimpse of the Unix in your Mac, open a terminal window and type man-roff to view the Unix manual entry for an early text formatting program that lives on within your operating system. 2019 marks the 50th anniversary of the start of Unix, which happened in the summer of 1969. That same summer saw mankind's first step on the surface of the moon. Computer scientists at Bell Labs, most centrally Ken Thompson and Dennis Ritchie, began the construction of a new operating system using a then aging DEC PDP-7 computer in the lab, as Ritchie would later explain. What we wanted to preserve was not just a good environment to do programming, but a system around which a fellowship could form. We knew from experience that the essence of communal computing, as supplied from remote access and time-shared machines, is not just a type program, or not just to type programs into the terminal instead of a key punch, but to actually encourage close communications. And it goes on with more of the history of it. Most of us probably know that pretty well. But to say, with invaluable early reviews of these listings from Warren Tomei of the Unix Heritage Society and from John Mashley, an early Unix contributor, the Computer History Museum trustee, we can date these listings to 1970 and perhaps maybe early 1971, before the Unix effort migrated to a newer PDP-11 computer. A PDF of the listing contained in this Unix Book 2 binder is available for download via their catalog at the Computer History Museum. So you can see a whole bunch of the different commands and stuff that they have.
Yeah. Classic tapes.
Apparently, this one is a page of the source code from the program Space Travel from 1970. It was critical to the start of the Unix story. Ken Thompson began implementing the science fiction game in which players guide a spacecraft through the solar system to land on various moons and planets on the PDP-7 at Bell Labs in 1969. Dennis Ritchie, who joined in the effort in working on and playing Space Travel on the PDP-7, Thompson turned to developing a full, if fledgling, operating system for the computer that incorporated a file system and other ideas that he and other computer science departments had been considering and working on. Ritchie and other colleagues were soon attracted to the system and its development, and that early system, the start of Unix, and programs for it are represented in the source code. And importantly, that whole idea of having that fellowship of people actually communicating and building the software is how we ended up with kind of the open source ethos and so on that we have today.
Mm-hmm.
They have some annotations from this book of source code, including things like the PDP-7 assembly listing for the program Moo, which is a number guessing game that originally came from Multics in 1970 and in 1968 on the University of Cambridge mainframe, a version of the Minder paper game Bulls and Cows. which I've not heard of before.
Yeah, that's new for me as well.
Then pages 45 to 63 are the PDP-7 assembly listing for a game they can't quite figure out, but it may be a simulation or game having something to do with pool or billiards.
Gaming is a universal thing, I guess.
Yeah. And then page 67 to 71 is for a program called Psych, which might also be some kind of guessing program. It's trying to be a psychic or something.
Oh, maybe an early ELIZA program.
Something like that. And page 94 to 98 is a listing for the program Salve, which apparently some kind of file system salvaging tool for reconstructing a file system.
Way back when they had that problem.
And then they have TTT1 and TTT2, which are two different versions of tic-tac-toe from the look of it.
Yes, the computer always wins, and it's the best move not to play, of course.
Well, because there's two different binaries, I wonder if it was actually meant for two different people to play on different consoles or something.
Oh, yes. You start TTT1 and I start TTT2.
Player 1 and player 2, maybe.
Yeah, that could be.
Anyway, there's lots of good stuff there, and you might want to check that out. And then this morning, this other news story popped up in my newsfeed, and I decided to check it into the show. Over on CBC Radio, they have a program called The Current, and they just did an interview with Leonard Kleinrock, who was the person who actually sent the first message over the internet. As we've told about before, the first online message was sent between two computers and was just the letters LO. And that was sent pretty much 50 years ago to the date when we're recording this, on October 29th, 1969. Now, of course, it was supposed to be apparently the word log or login.
Login, yeah.
But the computer sending the message crashed before it could send the third character.
So classic computer science way back when, yeah.
So this was a computer at UCLA trying to send a message to a computer at Stanford, which was 560 kilometers away. So this radio show in Canada called The Current has a full half-hour interview with Leonard, and definitely recommend checking that out. But we've excerpted a couple of the especially juicy questions and answers for you. They talk a little bit about the background, saying the idea of a network was you sit at one computer, log in through the network to a remote computer, and use the services it provides, which turned out to become the central model for the whole internet. As you have your one computer, and then you access services on a different computer.
I think we can put a check mark on that. Done.
50 years later, the internet has become so ubiquitous that it is almost rendered invisible. There's hardly an aspect of our daily lives that hasn't been touched and transformed by the internet. So getting to the questions, the first question they say is, take us back to that day 50 years ago. Did you have a sense that this was going to be something you'd be working on half a century later? And the answer was, well, yes and no. 4 months before that message was sent, there was a press release that came out of UCLA in which it quoted me as describing what my vision for this network would be. Basically, what I said is that this network would be always on, always available. Anybody with any device could get on at any time from any location, and it would be invisible. Turns out it was pretty prescient. But, he goes on, well, what I missed was that this is going to become a social network. People talking to people. Not what I envisioned, computers talking to computers. But it turns out there's this whole human element to it.
Yeah.
And then going on, and I say, can you briefly explain what you were working on at the lab? Why were you trying to get computers to actually talk to one another? And he says, as an MIT graduate student years before, I recognized I was surrounded by computers, and I realized there was no effective or efficient ways for them to actually communicate. I did my dissertation, my research on establishing a mathematical theory on how these networks would work. That was switching theory. But there was no such network that existed. And AT&T said, no, your thing won't work. And even if it does, we don't want anything to do with it. Anyway, so he says, so I had to wait around for years until ARPA, the Advanced Research Project Agency, later becoming DARPA, within the Department of Defense decided they needed a network to connect together the computers the scientists they were supervising and supporting were using. And we get question, for all the promise of the internet, it has also developed some dark sides that I'm guessing pioneers like yourself never anticipated. And the answer being, we did not. Originally, I knew everybody on the internet at the time, and they were all well-behaved, and they all believed in an open, shared, free network. So we did not put any security controls in place. When the first spam email occurred, we began to see the dark side emerge as this network reached nefarious people sitting in basements with high-speed connections. Although I'm guessing when he says high-speed there, meaning relative, when dial-up was fast compared to what people had been using before. Anyway, reaching out to millions of people instantaneously at no cost in time or money, anonymously until all sorts of unpleasant events occurred, which we called the dark side of the web. But in those early days, I considered the network to be going through its teenage years. From hacking to spam, annoying kind of effects, I thought that one day this network would mature and grow up. Well, in fact, it took a turn for the worse when nation-states, organized crime, and extremists came in and began to abuse the network in several different ways. And then a follow-up to that is there any part of you that regrets giving birth to the internet? And he says, absolutely not. The greater good is much more important. There's a full half-hour interview with lots of interesting stuff in it, and I recommend you go check that out.
Okay, let's go right into the news roundup this week. We have found a tutorial on how to use blacklistd with NPF as a fail-to-ban replacement over at unitedbsd.com. And they describe blacklistd as, first of all, blacklistd provides an API that can be used by network daemons to communicate with a packet filter via the daemon to enforce opening and closing ports dynamically based on the policy. So the interface to the packet filter is in libexec blacklistd-helper, currently designed for NPF. This is the NetBSD's PF. And the configuration file, inspired from inid.conf, is etc blacklistd.conf. So first, they need to set security levels or secure levels. As they're likely planning to expose our workstation to the internet, it is advisable to raise the level of security in the system, in this case, the secure level, at least to 1, the secure mode, with -1 being the default mode, permanently insecure mode. And if you want to know more, there's the man page secmodel_secure level. So let's enable the secure mode by specifying secure level equals n, in this case, the level you want to have. And this is done in rc.conf in etc. And this will let init take care of it upon boot. So you can only change that upon boot, and you can only raise the secure level afterwards. You cannot lower it anymore without rebooting the system. So that's done. So after the next boot, we have a secure level of 1. And then we can enable NPF, BPF JIT, and NPF log in secure mode. So this implies that with secure level now at 1, that the kernel modules may not be loaded or unloaded anymore, and adding or removing sysctls or nodes is denied. So that's secure and will not be changed anymore, unless the system is rebooted and the secure level is lowered. Now, blacklistd will require BPF JIT, which is a just-in-time compiler for the Berkeley packet filter, in order to properly work, in addition to, naturally, the NPF, the packet filter itself, as a front-end, and syslogd as a backend to print diagnostic messages. Also remember, NPF shall rely on the NPF virtual network interface to provide logging for TCP dump to use. Unfortunately, don't ask the author of that article why. In 8.1, that's NetBSD, all the required kernel components are still not compiled by default in the generic kernel and are rather provided as modules. So enabling NPF and blacklistd services would normally result in them being automatically loaded as root, but predictably on secure level equals 1, this is not going to happen because, again, you can't load modules. So there are 2 ways out there to deal with that. Enable them in the kernel config so that it's part of the running kernel. And they describe how to do that. Or the second step, or the second way, make init load them at boot by resorting to modules.conf. And there you list that one. Okay, so after that's done, you can actually start configuring blacklistd. A suitable blacklistd conf is listed in the article. And there's a couple of sections there that are important. So it has 7 columns, I'm not sure. Yeah, it's 7 columns. And each one has a separate set that needs to be part of the rule set that you're writing. like when should blacklistd act and what it should do when a certain threshold is reached, and things like that, how long it should block users or IP addresses, things like that. So then make npf use blacklistd, because at the moment, blacklistd is still a thing on its own. It doesn't know anything about which firewall it should talk to or send its results to. So it's wise to back up your former npf conf, and you can check that into version control or just make a backup copy with a date timestamp on it so you know when you did that and can get back to it. So let's update the npf conf. Therefore, you're referring to the stateful firewall example there, and you enable that by setting bpf.jit to on, and a little further down, there's rule set blacklistd-desk that you set. Next, you restrict the permissions to root only. So you do a change mod on etc npf.conf so that only root can actually manipulate or even see that rule set. Then you update the npf rule set. So you flush the current rule set and then reload that one so that you get the new lists or the new rules loaded into the firewall. And then you enable the blacklistd by setting etcrc.conf, the blacklistd equals to yes, and then start the service blacklistd start. And to perform some tests, you should now have a local table and a remote table. So that's always part of the blacklistd way of working. And the local table has the wide area network clients. They shall be banned for 24 hours after 3 failed authentication attempts. These are the people nagging your SSH ports all the time or other ports that you have open. While the remote table, which takes precedence, introduces a milder policy for local area network clients, implying they can try to authenticate up to 9 times because some users are a bit more clunky with their typing maybe, and they're not actually attacking you from the inside. Although your mileage may vary, but as an example, this is perfectly fine. So your local folks get a bit more time before they also get blocked or rejected. And you can also see what the current list is, what kind of addresses are blocked and how long they are still blocked by running blacklist ctl dump -a and b. And that will list the addresses, like at how many fails there are. Are they still over the threshold? Or in this case, it's 3 attempts out of 11. And then the last access mode. And if they are blocked, they will also show with a different set of settings in blacklist cuddle how long they are still blocked. Maybe they're blocked until next year. Maybe they're just blocked for the next 24 hours. But this is up to you to decide in your blacklistd configuration. And I also put the introduction chapter, this is not directly related to this one, for FreeBSD's blacklistd, which is basically coming from NetBSD, but how you can use that. And it also explains how blacklistd works and what each column is doing in the config file. So that's hopefully a nice additional read for setting up your own blacklistd.
So on to the next story, we have OpenBSD has crossed 400,000 commits. So this is an email to the OpenBSD tech list from Theodor Ratt a couple of weeks ago, saying sometime in the last week, OpenBSD has crossed 400,000 commits, with a little star about a footnote there, upon all of our repositories since we started back on October 18th, 1995. So just in time for an anniversary there.
Ooh.
He says, that's a lot of commits by a lot of amazing people.
Oh, yes.
But he notes that count of 400,000 commits is by one measurement. Since the repository is so large and so old, there are a variety of quirks, including changelogs that are missing entries and branches that are not convertible to other repo formats. So measuring is really hard. If you think you've got a great way of measuring how many commits there have been, don't be so sure of yourself. You probably have over or undercounted in one or more ways.
Yes.
Now, sometimes it will average out, but yes, it turns out counting commits is really difficult.
Oh, yeah.
So keeping that in mind and knowing that I did even less work than Theo did, I quickly looked at some of the other BSD projects. NetBSD plus all of package source is on its way to 600,000 commits. Of course, package source covers a bunch of other operating systems too, so that's maybe not a very fair comparison. And then looking at FreeBSD, I think it was at 925,000. meaning that it will hit 1 million commits sometime probably relatively early next year. That being the base, ports, and docs repo. So that gets pretty big pretty fast.
Yeah. Is OpenBSD, so for OpenSSH and the other sub-projects they have, is that the same repository or do they have separate ones?
So there's the version of OpenSSH that's built as part of OpenBSD, and then separately, I think it spins out into a repo that makes the portable version.
Yeah.
Maybe not for OpenSSH. For some of the stuff like LibreSSL, I think OpenBSD is the repo of truth, and then they have a portable version they make on the side. But I think OpenSSH has its own repo. I'm not actually entirely sure.
Because then you would have all these sub-projects.
Yeah, because that could result in a bunch of commits being converted down into one commit before they show up in the various BSDs. Because I know I thought about that a little bit when looking at the number for package source, because they have the package source work in progress repo, where oftentimes a bunch of work happens in a port before it actually gets committed into the package source repo.
Yes, yeah.
And it's like, well, do we count those or not? Mm-hmm.
Yeah, projects branches that are not maybe seeing the light of day, just experiments.
So in FreeBSD, the project branches are counted in the count I gave.
Okay, yeah, so as a relative number. But yeah, it's definitely some milestone they reached. And again, since 1995, that's a number.
And they hit that round number really close to an anniversary, which is extra interesting.
The next thing that we have is how to install Bolt CMS with Nginx and Let's Encrypt on FreeBSD. That's FreeBSD 12, of course. And if you are asking, what is Bolt? Bolt is a sophisticated, lightweight, and simple CMS, content management system, built with PHP. It's released under the open source MIT license, and source code is hosted as a public repository on GitHub. Bolt is a tool for content management which strives to be as simple and straightforward as possible. It's quick to set up, easy to configure, uses elegant templates, and is created using modern open source libraries and best suited to build sites in HTML5 with modern markup. So here they walk us through setting that up with Nginx as a web server, MySQL as a database server, and you can secure the transport layer. That's not optionally, that should be mandatory by now, by using the Acme SH client and Let's Encrypt for certificate authority to add SSL support.
Well, you could buy one instead if you wanted to.
Sure, right. But it's definitely not optionally anymore to have no SSL support of any kind. So they go through the requirements. That's pretty much covered. And prerequisites is basically having an operating system running FreeBSD 12 and a non-root user with sudo privileges, so you can switch in case you need privileged operations like package installs. They go through some FreeBSD steps like the time zone setup. I guess that we can skip that. The first important thing is that you update your FreeBSD package database by package update and package upgrade-y to get the latest sources and versions here. Then you install the required packages. In this case, it's some basic stuff, sudo vim. I guess people can pick their own software here. What we need for the actual Bolt is MySQL 5.7-server, or the current version that might be out by the time you read this. And you check the MySQL version. That's the proper one. By running MySQL -version. Yes, that's the one we want. And then you run sysrc MySQL _enable equals yes, and service MySQL -server start so that it's running, and it will also run when your server or system restarts. Then you run MySQL _secure installation. That improves your MySQL security a bit and sets the password for the MySQL root user. Okay, so far so good. Then you connect as the MySQL, as the root user to the MySQL shell, and create your first database in whatever it might be. It could be Bolt, to remember what it was for. Create a user that is identified by a password that you should type when no one's sitting next to you or looks over your shoulder, and then flush privileges and grant all to that user so that you have proper permissions. All right, then you start with the PHP install. That's pretty much a bunch of PHP packages. I guess they will pull in the needed ones that are missing.
Yeah, so I think they listed all of them specifically here, although I think most of them, if you install the wrapper package called PHP 72-extensions. It pulls in most of these by default, but a couple of them not. So yeah, you can just say, give me all of these dependencies, and then enable and start PHP FPM, which gives you a fast CGI worker setup for your web server to pass to run the PHP code.
Then step 3, you install the Acme client and obtain Let's Encrypt certificates. That's again optional, but it's fairly easy. You do package install acme.sh and check that version. It's 2.8.2 at the time of this writing. And then you obtain the RSA and ECC, ECTSA certificates for your domain. Running acme.sh-issue, you want a standalone one for --home, etc. Let's encrypt -d your domain name, and then the key length of 22048 could be higher, but that's definitely a good port.
That's the minimum actually nowadays.
Yeah, never go lower. And the same for ECDSH by just switching the key length to EC-256. Okay, once you have those, you install Nginx and configure that. So you install Nginx. Why do they install the devel version? Maybe they want newer versions. You can also just install Nginx, the default. They also do the sysrc dance, adding that to rc.conf as well, and start that Nginx service. And then you configure your Nginx. They have a separate Bolt config that is for that server only, where you define your SSL certificates, where they are located on your hard disk in your folders that you set in acme.sh, and then some locations where the actual files are that you serve, and also some PHP fast GGI parameters. Then you test that configuration. Always do that before starting the service, because you might have typos and things like that.
Well, the Nginx reload and I think restart command specifically do that test before trying to issue the restart. Because if the test fails, the service won't start. You don't want to say stop, start if it's not going to work. So it runs the test first. Luckily, that's built into the service wrapper for Nginx.
Yep, excellent. That's good. And then you install the actual Bolt CMS on that, because so far we have only installed a web server with SSL certificates. And that's located on the user local www. If that's not existing, you can just make that one.
Oh, they're not using a package, never mind.
Yeah, or you create a data set for it on ZFS, and that's basically boiling down to the same thing. And then, there's not a package. Again, as Alan mentioned, you do a wget or a fetch, and then unzip that into the directory. And then you move a couple of files around for renaming purposes. Yes, they have some dist files, and they need to be without the dist extension, so you need to rename that.
Basically, it's like the .example or .sample that we use in the ports tree.
Once the show is out, people will run and make a port out of it to make that step go away. And then the rest is basically done in the web itself. You run that CMS setup in your browser, and it walks you through setting up your website or your content management systems with users and websites and everything that you need from there on. Very cool. Very straightforward.
Yep. Next up, we have a story about Hammer 2 optimizing support threads. So this is a commit from a couple of weeks ago, optimizing Hammer 2 support for threads and direct dispatch. So they've refactored the XOP groups in order to be able to queue even the strategy calls. So when you're doing reads and writes to disks, a lot of the underlying stuff has a strategy subroutine that tries to find to optimize stuff and make sure that you can combine and don't make the head skip all over the place unnecessarily. So now, whenever possible, those are queued on the same CPU as the original issued thing. So in the past, when you'd queue up a bunch of these commands, the queued command might end up running on a different CPU, whereas now they try to keep it on the same CPU as the original request. This optimizes several cases and reduces unnecessary interprocessor interrupt traffic between the different CPUs. The next best thing to do would be to not queue certain operations at all. Not send them out to be run in a Hammer 2 support thread. But Matt would like to keep the current setup with those threads intact, because the clustering work we'll use that later, since those operations will actually have to be synchronized across machines. and therefore it'll make sense to have them in a separate thread. So while you could get a bit more performance by removing that, it would break the future feature that they're working on there. They say the best scaling case for this is when you have a large number of user threads doing I/O. One instance of a single-threaded program on an otherwise idle machine might see a very slight reduction in performance, but at the same time, we've completely avoided unnecessarily spamming all the cores on the system on behalf of a single program. So the overhead reduction probably makes up for most of that anyway. It says this will tend to increase the number of Hammer 2 support threads that get created, since we need a certain degree of multiplication for domain separation, so that especially if you're running on some of the newer AMD hardware, we have many different domains. You need to have some threads in each domain so that when you're trying to dispatch to a thread, there's one in the same domain as you that's not already busy. Anyway, it says this should significantly increase I/O performance for all your multi-threaded workloads. Nice to see that kind of work going on in Hammer.
Yeah, they seem to innovate on that file system in their own certain interesting ways. Yeah. We'll watch this space. Okay, and now for the namesake of this episode. We might as well just run every network service over HTTPS 2 and build another 6 layers on top of that to appease the OSI 7-layer burrito guys.
I just like the way the whole website is described. So the website is called The Boston Diaries, and it says, the ongoing saga of a programmer who doesn't live in Boston, nor does he even like Boston, yet he named his weblog/journal The Boston Diaries.
But as this little intro commences, so the author here has been writing on the wall, has seen that. Yeah, he has
seen the writing on the wall. That means something completely different than writing on the wall.
Yes, okay. So walls are clean, but he has seen the writing from other people on the wall. Okay, so, and while for now you can configure Firefox not to run DOH, that caused a bit of an uproar in the internet. Yep. I'm not confident enough to think it will remain that way. To that end, I finally set up my own DOH server to use at Shezboka. It only involved setting up my own CA to generate the appropriate certificate, install my CA certificate into Firefox, configure Apache to run over HTTP 2. Thank you very much, Google, for giving that to us. He's not bitter, he writes. Okay. And write a 150-line script that just queries my own local DNS because, it's more secure or more something. Good reason like that. And then I had to reconfigure Firefox using the advanced configuration page to tweak some settings. They are listed on that page, of course. And after setting network.trr.mo to 3 instead of 2, because it's coming, author here knows it's just coming, so he might as well get ahead of the curve. Okay, so he basically sets his own DNS instead of the DOH that no one likes.
Right. Well, so instead of trying to just disable DOH, he switched it to use his own local DOH, which lets him downgrade it to a regular DNS request.
Mm-hmm. Yeah, this is perfectly fine. It might not be something for Joe, default user, but with a little bit of scripting, and the 150-line script is also linked there. So that's a Lua script, by the way. It's doable if you want to run your own DNS and don't want to trust big corporations doing that. Perfectly fine to do it on your own. All right, it's time for the Beastie Bits this week. We also can't stop giving you a little oral history of Unix, and that's what we did. Here's a link to Princeton, and they have an oral history of Unix. These are transcripts from a number of people that you might have heard of. Dennis Ritchie, for example, Peter Weinberg, Ken Thompson, and yes, they are transcripts from interviews. I originally thought they were lectures, but yeah, they're interviews.
No, these are interviews when they were building the oral history of Unix. So it's definitely a good read.
Yep. So to hear the original Unix folks talk about how they did it, why they did it, and other things around it. Very cool for the rainy days that are coming, maybe in November. Okay, then we have NUMA siloing in the FreeBSD network stack. This is from Drew Gallatin. That's his EuroBSDCon talk. Oh yes, I remember this one.
It and a bunch of the other ones are up on papers.freebsd.org, and the OpenBSD ones are up on OpenBSD's paper site as well. And good news, the videos have shown up. So thanks to Patrick McAvoy and the rest of the people that worked on video at EuroBSDCon for getting those out for you. So we have a link to the playlist that has the videos of all of the talks from EuroBSDCon. I think some of my favorites were the opening keynote, Paul Vixie's talk, Werner Losch's Unix history talk, and then everything else I watched while I was there. And there's also a bunch that I'm hoping to get to see, because some of the ones I really wanted to see were at the same time as other ones, or at the same time as the one I had to give.
Yeah. I also saw that the recording for the Dev Summit is also up.
Did we recorded the Dev Summit?
Yeah, they did the first day of the Dev Summit. The second one was the hackathon, but the first day they did the whole the quiz we did and all the introductions. The audio is sometimes bad when there's people talking in back of the room, but for the presentations that were given, they are all on tape.
That's good. And I think one or two of the tutorials were in there even.
Oh, were they? Oh, cool. That's certainly helpful.
Lots of videos. You can go watch them. Everybody's happy.
Yes.
But if you find any of the PDFs for slides and stuff missing on the papers at FreeBSD.org, you can find those and hook it up on our GitHub for that. And we'd love somebody to go through and add the links to all the videos. It's only a couple of minutes work. It's pretty easy to edit the front matter and markdown and just do it. Just need somebody to do that and create the pull request.
Mm-hmm.
So thank you.
Especially, those who did the talks. Okay. Next we have Barbie Knows Best. That's a tweet from someone who posted a picture.
Yes, it's from a book or series of comics or something that came out a while ago, where people found that it was very easy to change the text on the images. And so in this case, Barbie is handing one of the other characters a CD and says, "This ought to make sure we don't get any more viruses." And the person she's handing it to responds, "Oh, is this an antivirus installer?" And she says, "No, something better. It's FreeBSD."
Yeah, that's very nice. So in case you're wondering what you should do, in case you haven't run FreeBSD yet, the next item that we have here is for the OpenBSD E2K19 attendees. They did a pre-visit today.
So this is pictures from Bob Beck where he went up to the cabin that they're going to use for the OpenBSD hackathon and was getting it all hooked up for them.
Yes.
This is at Elk Lakes Provincial Park in British Columbia, where there's quite a bit of snow on the ground already. And so there's pictures of the wood stove and getting that cleaned up and ready so that they can keep warm, and the big table where they all sit and work or eat and so on, and a bunch of other nice pictures. There's the picture of the outhouse that they will get to use. The wood pile they will use to keep warm, and the swath through the trees where the power lines come in so that they will have some electricity. And you can see the mountains and so on in the background. And
yes, beautiful Canadian scenery.
According to the comments, they will actually hike in their own satellite internet unit to get internet while they're there. And only Canadian passport holders will be allowed to put wood in the fire.
Yeah, okay. They should be fine, yeah. And I guess we'll see a couple of reports from that hackathon, so happy hacking.
It'll be interesting to see what they work on.
And yeah, it's always an interesting setup and where they are hacking and what comes out of it. Then we have a drawer find from someone also on Twitter who found an old OpenBSD 2.8 CD-ROM.
In a drawer, basically.
Oh, it's still there. CD1 has the i386 PowerPC and the VAX version, whereas CD2 has the SPARC, Amiga, BP300, Mac 68K, MVMe 68K, and Sun 3. And an integrated X386 3.3.6 current.
So that must be before Xenokera.
Mm-hmm.
I didn't know exactly when that came about.
Yeah, but just the artwork is just beautiful. Just having that is cool.
And then someone replies where they have a copy of the OpenBSD 2.9 CDs, which have much less impressive artwork.
Yeah, that's right. That's a little less impressive. Yeah, but they had different artworks for each release, and they still do. So that's a nice way to get a little bit of nostalgia down.
Well, if you're interested in OpenBSD art, watch the next episode.
Hint, hint. The last item we have is slides from Asia BSDCon 2019. It's been a while in March this year. Removing RUP gadgets from OpenBSD.
So this is the 99 slides that Todd Mortimer had in his talk. So if you're interested in that, you check it out.
Contains a lot of hacks and assembly.
And now for the feedback.
Yes, feedback time is always the time where we remind you that you should send us feedback, not only about the show, any items that you found interesting, but also stuff that you found or things that have always been on your mind, but you were just too shy before to send it to us. If you have questions, get stuck somewhere, needed help in any way, send all of this to feedback@bsdnow.tv and it will make a future episode in this particular section. The first one who did this is Bastian, who did that before with other questions. And this one is about open source doesn't mean secure. So Bastian writes, "Hi all, I'm sending you a link you might discuss in the BSD Now show, which we're currently doing. IR Critical Watch Report is the thing. His takeaway from the report is that sadly there are a lot of businesses that don't update or upgrade their used software. There are a lot of reasons why they don't do it, but at the end it boils down to money. Even free open source software is not free. Sooner or later you have to pay for something regarding this free open source software."
Yeah, it always takes admin time to keep it up to date or whatever.
Yeah.
So in the report, they identify some of the biggest threats. The first one actually being encryption-related misconfigurations. It was always an interesting one where people, they think they're encrypting something, but they're either not actually encrypting it or they're encrypting it very weakly because they're, missing a setting or using the same key on everything or something like that. In the cloud environments, they find that people are not using encryption properly or that their online storage configurations are not right. So, for example, they have S3 buckets that are open to the public. They put private data in them, and then people steal it. That story has happened quite a few times in the last year. And so people need to watch for that. But also, most unpatched vulnerabilities that they found when surveying small and medium-sized businesses were more than a year old, meaning that, the vulnerability has been known and the fix has been available and it's been a year and they still haven't installed it.
Yeah. They make it very easy nowadays to install these, better than just, you patch this crazy thing.
Well, in particular, most people fall into one of two camps. Either you install the security updates pretty quickly, or you don't install them at all.
You forget about it, yeah. Or are too lazy to do that, yeah. And then it hurts you because these things are exploited nowadays. They're not there to just laugh about them. It's serious stuff.
Yeah. The sixth biggest threat is unsupported versions of operating systems, whether that's Windows or Unix or whatever, but running software so out of date, distributor doesn't provide support for it anymore, meaning there are no updates. So when the vulnerabilities are found, you don't get a fix. Or outdated Linux kernels are present in nearly half of all the companies they surveyed. Now, oftentimes that's because it's embedded in something that you might not even know is running Linux, but they don't get updates.
Yeah.
But also they found a lot of low-level devices end up running an FTP server that people don't necessarily know is there. And, default credentials or just completely open, and then people can use it for all kinds of nefarious things. And email servers tend to be old and vulnerable in a lot of people's installations. Probably less so on the BSDs, but again, the idea being if you run your own mail server, you probably run package update every once in a while. But if you're running a version of BSD that came out 5 years ago and isn't supported anymore, and you've not updated the packages, then your mail server is probably not in a good way.
Yeah. The chat room also points out that or your management won't let you update because it's working fine as it is. Mm-hmm.
Yeah.
Sound familiar?
Mm-hmm.
Yeah, so everything's better if you let the sysadmin do the updates if they're not breaking your current running system more than the hackers would.
Now, this next feedback has the best subject line I've heard in a while.
Yes, because it is. Alan is correct. Well, we all know that is mostly true most of the time.
I was like, what could this be about? When was this in doubt?
I guess it came up from one of the discussions we had at VBSDCon.
Yeah, well, I think it was the VBSDCon recap when we talked about it.
Mm-hmm. So the feedback is 2 sentences, very short. DS9 is the superior Star Trek, hands down, period.
Yes. So to echo that back, yes, Malcolm is correct.
Yes. Yeah. So we leave it at that. No discussion. Everything is clear. Why was that? Okay. Ever disputed? No. Okay. Last but not least is Michael with FreeNAS inside a jail. Sorry. Michael writes, "Hi Alan and Benedict. Quick question that I haven't been able to find online resources for. Do you guys know if it's possible to install FreeNAS inside a FreeBSD jail? I've not got... he got physical co-load hardware that's easiest to run vanilla on, but I'd like to do some FreeNAS stuff too. I do need to break down and make a Beehive VM, or I can get things going in an IO-caged managed jail."
So it would be difficult, and FreeNAS definitely probably wouldn't be happy about it, but it might be possible. It can also depend on your configuration. Like if the host OS is just going to use like 2 drives for the OS or whatever, and then you're going to give the rest of the disks to the FreeNAS, that could make sense. If you already have a zpool with all your space on the host, then what are you going to give FreeNAS for disks? It's probably not worth the effort. I don't know how you would run the FreeNAS installer to get it to work in a jail, and it'd be complicated and fragile. But it's possible.
Yeah, it wouldn't be a very normal, or the setup you would normally do, but yeah, with a bit of tweaking and coding or setting things up the way it should. I don't recall seeing any tutorial how to do that.
Yeah, like figuring out all the quirks to get this to work would be a lot of work. So it's theoretically possible, but I don't know that anyone's ever succeeded at it because it would be quite a bit of work.
Yeah.
Because you'd have to have custom stuff to make sure that the disks were actually visible so that dev in the jail has actually got access to everything. So it's hardly a jail. And so if it actually had access to be able to do the disks and a couple other things, it might kind of work. But you'd run into all kinds of weirdness too.
Yeah.
Like you'd have to give it special permissions to be able to do mounts. I don't know if zpool import is even allowed inside a jail. Like you can delegate a data set inside of a jail, which makes root in the jail able to use it. But that doesn't actually work at the pool level. So it might not actually be possible to create and operate a pool from inside a jail just because ZFS restricts that on purpose.
Mm-hmm. For good reason, yeah.
So probably not advisable. A Beehive VM is maybe slightly better. It depends what you're wanting to do with the FreeNAS, because if you already have vanilla FreeBSD, you probably don't really need a FreeNAS. All the services provided by that can be done on vanilla FreeBSD pretty easily. You might actually want to check out Dave from the chat room here, Monkey, had to give a talk at VBSDCon, where the video and slides for those are both available already, on how to actually switch a running FreeNAS over to vanilla FreeBSD. And that basically covers how to set up most of the basic stuff you might be trying to run FreeNAS for on your vanilla FreeBSD machine anyway.
Yep. So this shouldn't be done by newbies who are starting out with FreeNAS. So
yeah. So it's definitely not easy, and it might not actually be possible. And I definitely don't have a week to go try to do it.
Yeah, it would be a bit of a work that could be spent different ways or better, I think. But definitely an interesting thought. If someone else has done this, but just as an exercise on a rainy afternoon, then send this to us as a follow-up. But other than that, pretty much this episode is over now. We thank you for listening and hope to you tuning in to us next time. Thank you.